Welcome to the podcast, Luna.
Thank you for having us.
I'm really excited about that, all the way from Canada. So maybe first off, tell me about what's going on with the face mask.
Good question. So, COVID hit. So when we were here just last week, we actually had a business meeting where we were potentially exposed to someone who tested positive, and that's why we wanted to take the precautions. We quarantined for the last week or so, and today is our first day back out into the world, and we want to make sure that just in case we wear face masks and ensure that no one else tests positive because of us.
Yeah. Of course, that's the responsible thing to do, and I really appreciate it personally. I just had Christmas cancelled as came to show that some relatives from Norway and Sweden were supposed to visit, but Norway just had a lockdown. So that's not going to happen. So sad, but that's just the way it is. Luna, you're the CEO and the founder of Genecis, and I was wondering if you could share a little bit about your own story. So what's the story behind Luna before we go into the nitty-gritty of Genecis?
Sure, great question. So I grew up in China up until 8 years old. One of the most polluting cities in China is actually where I grew up, so really saw climate change firsthand myself.
What's that city?
Shijiazhuang. It's near Beijing. It's very known for its industrialness. So there's a lot of pollution, lots of smog everywhere. People are always burning crops, and really got a chance to witness it firsthand myself, really. So that was when I was 8 years old. Came with my family to Canada, and where I really just thought that I loved science and loved technology. So studied science as well as technology back in school, and went for a Master's in Environmental Science in the University of Toronto, where basically looked at various different kinds of renewable energies as well as biotechnologies, and using that to see how we can create a better planet, really. And
wow. So that's kind of the story about growing up close to industrial pollution, and then actually starting to take the steps to educate yourself on how to change that. That is super cool. Thanks for sharing that. When you mentioned that you were looking at renewable energy and bioengineering, so how do you see renewable energy and bioengineering sort of playing together? What's the connection there?
Yeah, I think they're super related. So I think during my master's, I actually got a chance to stumble upon bioenergy. So creating biogas from food waste, right? Really got a chance to work with biogas plants who essentially operated these huge fermentation vats where you take food waste and then make them into biomethane, which can then be used as a renewable natural gas, right? And pretty quickly into that field, I learned that it was actually a very unprofitable business, and they really struggled to really make a lot of money out of that endeavor, even though it was such a sustainable and great endeavor, right? So I thought...
Maybe you can walk us through the different kinds of gas, because I'm not sure everyone who's listening in sort of knows what are the applications of gas, and what is the difference between natural gas and biogas, for instance.
Okay, sounds good. So I think gas in general is just something that you can burn, right, to create energy. And that's what really some forms of gases are used for, whether it's petroleum gases or natural gas or biogas, right? Biogas is essentially just a type of gas that's made from organic materials as opposed to petroleum crude oil, right? And for us, bioenergy has lots of different use cases, most namely in electricity. So it's a great way of basically producing power from a renewable biomass generation, the feedstock.
Okay, so you can essentially grow what will turn into sort of the electricity producing energy source in a way.
Exactly.
All right, cool. So seeing that as being interlinked and recognizing that the business case wasn't really there for biogas, what seemed to be the obstacles for it to become profitable?
Really good question. I think the biggest obstacle was really the bacteria. And usually in fermentation, what happens is that you actually feed some sort of a carbon source to bacteria within the fermentation vats, where then they produce the end product, right? For biogas, they would feed food waste to bacteria to generate methane, right?
Okay, yeah, so I'm just wrapping my head around. So the the carbon input will typically be food waste. So that's the organic waste, where most things have carbon here on this planet, and you take some of that organic material, you put it into the fermentation process, and the byproduct from that fermentation, normally we know fermentation from baking and from making beer or wine or anything the likes. But in this case in point, we're trying to get methane as the byproduct.
Exactly.
Or end product, I suppose.
Exactly. And even though it's such a great and cool process, the biggest challenge actually also lied in that process, in the sense that the bacteria that you use to make methane is a very slow-moving bacteria. It takes roughly 28 days for it to really grow and also produce the methane, right? And methane as a product by its own is also a very low-value product too. So that was really the biggest challenge. Bacteria was not efficient enough to generate a high-value product. And that's where we really saw an opportunity, where we thought, you know what, there's such a great carbon source within food waste, very similarly to how petroleum is a great source of carbons too, right? If we can feed it to much more efficient bacteria to make a higher value product instead, then we can really help to divert a lot more food waste from landfills and make them into renewable and sustainable products.
Okay, so actually in this business case, you're kind of also managing to actually avoid the sort of real political elephant in the energy room, which is the subsidy of fossil fuels. But even being able to circumvent that by providing a business case that's so good that it can actually beat a heavily subsidized industry.
Exactly.
Wow, that is super cool. I'm really blown away by that. Luna, now I've cheated a little bit, and I know what Genecis is doing, but I always feel a little bit foolish when I try to explain to someone what it is you're doing, because I end up sounding like a kid that's reciting a science fiction cartoon, right? If you were to explain the concept behind Genecis to a 5-year-old, how would you go about it?
Yeah, it's really quite simple. So really what we do is we make compostable or biodegradable plastics from food waste, right? And how that works is really through 2 types of bacteria cultures. The first type, you feed it food waste, and it produces carbon sources as a precursor. And the second type of bacteria essentially eats those carbons and makes PHAs within their own cells. And the last step is really just to take the PHAs from the cells of bacteria and make them into granules, much like the one that you see over here. This is really the PHAs.
So this is the actual plastic. When you say PHA, that's an acronym for
polyhydroxyalkanoids.
Yeah, everyone knows that.
Everyone knows that, that's right.
Okay.
And the really interesting thing is that what PHAs are is that they're actually the fat of bacteria. So all we're doing is we're actually just growing bacteria, extracting their fat, which has actually polymer-like properties or plastic-like properties, and making it into renewable plastic.
It's very hard for me still, even having heard this story time and time again during the past 2 years where I've been related to Genecis, to still get it. That, it's completely blowing my mind every time I hear that story. So you have a 2-step process. You start feeding food waste into a reactor. That can you say that it's kind of making a more linear form of the carbon?
Yeah, exactly. Yeah.
So it's kind of it's the first step of the blender in a way, where it makes sure that everything comes out in the same shape or same form that can then be fed to the second part of the process, where it's essentially grown into the end product by being fed to bacteria, and those bacteria grow a kind of, you say fat, that looks a lot like plastic, so it has the same properties. And if you were to walk us through sort of how do we make plastics today? What's the common way of making plastics?
Yeah, the most common way is using petroleum products, and it's usually synthetic chemistry. That's a multi-step process, right? Very polluting and takes quite a lot of energies as well as a lot of dollars to actually build up these large plants to do so, right? That's how you typically make plastics. With our process, it's a lot more natural, and it's actually much more simpler in the sense that everything is done within the cells of the bacteria, as opposed to huge mechanical processes that takes a lot of energies.
So you, instead of sort of finding an oil field and drilling for the oil, pumping the oil out, refining the oil, taking the crude oil, and then, I mean, I don't even know the steps you're going through there in terms of turning oil into plastic, but those steps you can basically remove. And then on top of that, there's the whole problem that the traditional oil-based polymers that we're using are not degrading in nature, and hence plastic pollution becomes a problem. That doesn't, I mean, in our line of work in Green Innovation Group, we're oftentimes busying ourselves with everything that's relating to greenhouse gas emissions, and not necessarily so much to environmental pollution, but the plastics problem is, in a way, it is or can be both, right? That there's both an emission factor, but more than anything, there's a huge sort of environmental pollution problem that the waste is not handled properly, and that is a problem because it doesn't degrade in nature. Whereas if we had the same problem with food waste and it would turn into the oceans, it would degrade in the oceans, and the problem wouldn't stay visible for as long as it does with plastic, you could say.
Exactly. You summarized it perfectly.
Thanks. I appreciate that. Now I feel like a winner. So you mentioned to me earlier that your vision of Genecis, sort of, well, what you're trying to build here is a company that can be accelerating the world's transition into biodegradable plastics or non-polluting plastics. Can you tell me more about that vision?
For sure. So really what we're trying to do here at Genecis is make these PHA biodegradable plastics a lot more affordable, right? And why do we want to make them more affordable? Is so that the world can actually buy them a lot more easier than right now. Currently, as of today, all PHAs are actually made by sugar sources, sugar feedstocks, which actually competes with the human food crops, right? But also it's really expensive. Things like corn and sugarcane that are used to make PHAs is extremely expensive to purchase on a very large scale, right? So with us, by producing them from food waste instead, which is actually a cost-negative feedstock, we can drastically reduce the production price point of PHAs by almost 40%. And that's really what we want to do for the future, so that we can really help the world get access to affordable PHAs that can then be used to make a variety of different kind of products, including most namely single-use plastics like 3D printing filaments, foodware, premium foodware, as well as biomedical applications. And that's where we want to be in the next 10 years, being able to be the leading producer of affordable PHAs in these three major markets.
That's amazing. And you have... I don't know if I'm going out of bounds in terms of strategy, but you've also found a way to scale that and to figure out where in the supply chain do you fit in. Can you share something about that, or is that confidential?
No, that's definitely something we love to share, actually. So it was actually during 2 years ago almost, during the YC program, Y Combinator program, that we were pretty much sort of advised by the YC partners to figure out a way to really sell our products into the market as quickly as possible. Right? That seemed like a really daunting goal at the time, because in the plastic industry, typically speaking, you need to have hundreds of kilos or even thousands of kilos of your product to give to people to test for free before they can say, hey, I can use this for a specific application. Right?
So that means in the plastics industry right now, the buyers of plastic or plastic materials are used to being able to get a test sample of a couple of 100 kilos.
Exactly.
And at that time, 2 years ago, you were able to produce
a couple of grams.
So you would be able to bring me one of those, and I would essentially need like a metric ton in order to make my purchasing decision.
Exactly.
Okay, so how do you overcome something like that? I mean, that sounds like an impossible task.
So that's what we thought too, right? But I think that's where we really discovered that we can't be putting these limitations upon ourselves. So what we did was we called up over hundreds of different kinds of brands who produced high premium kinds of plastic products, and see who of them were actually willing to be supporting us to do R&D projects or customization projects to work with us on such a small scale, being able to fund us as well as co-develop a product to take to market together, right? So that was quite a long process, talked to over hundreds of companies, and what we found was that we ended up actually having the fortune of actually working with some of the industry leaders in the premium food packaging, 3D printing filament, and the biomedical spaces who really urgently needed the properties that only PHAs could offer, and they wanted to be the industry forefront leaders in sustainability as well, wherein that they were willing to pay a premium in the very beginning and actually help to develop our company as well as a product forward together. So that's what sort of really drove our early partnerships, and seeing where basically customers were willing to do this as a sort of first mover advantage.
I think something that I've found quite interesting there, sort of in figuring sort of out where do you belong in the supply chain, that a lot of the collaborations that I know about that you have, they're doing something that's so different that it's actually in their best interest to help you develop the material, rather than you having to be scared about some intellectual property rights being compromised in the process, because you can actually trust that they're not going to go into plastic production, because they are already busying themselves with being world leaders in something quite different.
Absolutely.
Can you share sort of when we're looking at what it is we're doing now? We understand why this is a problem. We have the waste associated with plastic production. We have the degradability that's not there in sort of the traditional oil-based, fossil-based plastics. We have a solution here that is both addressing the food waste problem, and it's producing a high-value product that's also biodegradable, and we have industrial interest that's sort of helping speed up this innovation. What's a case example of something you've done, and what is your production capacity today by the end of 2021?
Great set of questions. So for us, one of the best case studies that we have right now is our collaboration with Novo Nordisk, right? We were super lucky to have actually won their 2020 Innovation Challenge, and now we're going to be able to really help them not only produce more PHAs, which is biodegradable material that they can use in their devices, but also we've been able to figure out a way to valorize their internal insulin production waste, which is yeast waste essentially, and convert that into making PHAs that can then go into their devices. And that's a super great circular story, and it's a project that we're super excited on working further with them going forward into the future. And in terms of production capacity, by the end of 2022, we're looking to have our first demonstration plant set up in Canada, funded by a most recently awarded project, $6 million Canadian, by the Canadian government, to integrate our technology with one of the largest biogas plants in Canada. And over here in Denmark, we're really looking to see if we can even have a larger scale from that by 2023.
Yeah.
So it's super exciting next steps, and it's really just about how can we get to scale as quickly as possible.
What kind of tonnage can be derived from that plant in Canada? By the end of 2023, will it have a production capacity, and how much will it be able to produce?
Yeah, we're looking at least, let's say, around 10 to 15 tons of PHAs per year. However, we're also going to be compounding that or blending that with other biodegradable resins and additives so that we can actually produce more for our customers in the immediate short term.
Yeah. So you're going to be able to deliver something in the market without producing all of it yourself.
Exactly. And that's something that's really exciting, really, in the entire biodegradable plastics today. Because if you look at it really macro-wise, bioplastics right now is less than 1% of the entire plastics market. Right? There's more to go around than anyone can handle, and we really see that in order for us to move as quickly as possible, we need to be collaborating with each other as much as possible.
Yeah, and when you say bioplastics, it's all plant-based plastics and not just biodegradable plastics. How much of that 1%, sort of if you had to slice that pie, how much of that do you think is biodegradable, and how much of that is non-biodegradable?
Yeah, good question. I'd say actually majority of the pie right now is non-biodegradable, right? More so just plant-based bioplastics. And it really depends on the application that you're trying to make. to figure out which one you want to be using. Are you looking to make something that's home compostable, which is like one of the highest in terms of biodegradability, or are you just looking for something that's more so industrially compostable or potentially just plant-based?
Yeah.
So I think there's a solution for every. And our dream, of course, is to make sure that we can gradually and, of course, as quickly as possible increase the market share of biodegradable plastics in general.
And I think that's a great vision. I think the true believers of sort of the circular economy and the double butterfly diagram by Ellen MacArthur will also be asking sort of, when you have a material that's this biodegradable, will it also keep its form if we want it to keep its form? So will we be able to bring it back into circulation and give it shape again? Or is it destined to degrade once it's sort of been used for that single use?
Mm-hmm. So I think that's a really interesting question. And I think one of the best solutions that's out there is something like PHAs, which is sort of like what we call a foolproof product, right? In the sense that if you put PHAs into a composting facility, it will compost within the timelines, and it can actually be used to make fertilizer that will return back to the soil. Right? If PHAs are degraded into a landfill or put into a landfill by accident because it's gone into the trash stream, right? It will degrade within a landfill also within 12 months, just returning back to earth, not causing any residues or pollution. But also, because PHAs has properties that's super similar to polypropylene and polyethylene, technically speaking,
those are, just for the ones that don't get it, those are oil-based polymers,
exactly.
Polyethylene and polypropylene.
Exactly, and that's what the existing recycling infrastructure is based on, right? So if by accident PHA also goes into the recycling stream, it could actually be recombined with polypropylene and polyethylene to form recycled resins too. So that's what we actually want to be doing in the future, to making sure that PHAs can actually go into all these different kinds of waste streams across various different countries, so that it can be taken care of no matter which stream it ends up in.
Wow. So you're saying there's even a potential that you could take a biodegradable plastic, you could grind it, and you could recirculate it into a recycled plastic that is combining with recycled fossil fuel-based or fossil-based plastics.
Exactly. Yeah.
Amazing. Without compromising the quality. Wow, that would be truly amazing. Luna, I feel like we've touched upon all of the subjects that we have, but just wrapping up, I would love to hear from you when now we've spoken about the near future projects, we've spoken about the sort of 2 years trailing behind us and the 2 years in front of us, but if I ask you to take the time machine to 2030, what does the world look like in terms of biodegradable plastics, and where are Genecis at?
Well, by 2030, we love to see if we can grow the entire biodegradable plastics market to at least 5% of the entire petroleum plastics market, right? Really increasing that market share to upwards of $50 billion USD. In terms of the entire biodegradable plastics market, and really focusing on the 3 markets that we see the most traction being, and also the most need for our plastics today, which is number 1, 3D printing filaments, number 2, premium food packaging, and number 3, biomedical applications. And it's really also something that we're super excited to do with our existing partners, as well as more partners that we'll have to be able to co-launch products together in these markets. That'll be amazing to see in 2030.
Amazing, and that is basically both the dream and the company vision, that market share is going to grow through partnerships, and you're going to grab your slice of that pie that we mentioned before. Do you think you will have applied it in 3D filaments by 2030, or is it going to be something that's in a very near deployment pipeline, or will it for certain be in the market by then? For certain in the market by then. Okay. Yeah, I'll say this. I think there's a lot of use of PHAs in all these 3 markets already. It's just a question of how much more can we make it by making PHAs affordable, and by us scaling that up, making sure that we have enough supply to meet the demands that we're seeing right now exploding in the market. Do you want to put some dollar estimates on what are the costs now, and what do you see them being? Sure. The cost of PHAs right now is roughly $5 per kilo USD.
right? 2030, we're looking to at least reduce that by half. And I think that's something that we really need to set as a goal, not only to strive to hit, but it's something that has to happen to really accelerate the world into that transition.
And what is the price comparison in the market right now for fossil-based plastics?
$5 per kilo is roughly 4 times more than PP and PE, which is the most commonly used plastics today. Yeah. So even by 2030, we'll still be quite a whiles away from actually being directly competitive with commodity-based plastics, but we love to get there step by step.
Yeah, but I'd also say that say we get a carbon tax, then I think a lot of the fossil-based products are going to be very challenged in their business models, as the whole byproduct from oil extraction industry is going to get a huge challenge in terms of survivability. If we manage to pull off subsidies, we're also standing a better chance of improving those odds. But thanks a lot for giving some insights into the market. I wasn't aware of those prices, so that really helped me with a sense of perspective. And thanks for sharing your story and what you're doing with Genecis. And it's amazing to follow it on the sidelines.
Oh, thank you so much again for having us today. Yeah,
of course.
Really appreciate it.
Any day you're in Denmark, you know that.
I'll take you up on that offer.
For sure. Cheers.